Yeah, we go through the basic, I would say that computer technologies or computer system. And then those are the fundamental things that you have to think about it or yeah, a little bit basic concept. But honestly, in our course, we focus on the AI and machine learning. So we will have a brief example to introduce some of the most interesting AI history and then the machine learning history. So don't think that AI is only this 10 or these 3 years. Honestly, AI they have a really long history. So AI start with the computer system. Once we have the computer system, we have the AI. So AI and then computer system start in 1950. So if you remember Alan Turing, right? Alan Turing, so invent the first computer. So he also invent the computer artificial intelligence. So how the computer should do it, and then what is the best AI thinking. So AI start with the Alan Turing, start with the computer system. And then they have a long history about AI. At the very beginning, AI is only if then else case. It's only a rule-based system that follow the human thinking, or we just use them to do some basic game playing to see that we can beat the AI can beat the human or not. Then later on, we think that, hey, I don't want to use the if then else. I don't want to code the rules one by one, line by line by myself. So can I have lots of the data set and then let the computer, I would say that let the AI to learn the relationship so that I just prepare the data and then you learn the relationship. You learn all the if then else rules for me. And that's why we have the machine learning. We have the machine learning. So machine learning here start because we have the lots bands, we have the lots of the email, and then because email is really easy to send out without any cost, just a click. So we have lots of the junk mail, and because lots of the junk mail, we have need a machine learning algorithm to identify this email is junk mail or not. So at that time, we have start our machine learning to identify the junk mail. So just like today, when you go to the Gmail and then you find, hey, this one is the junk mail, and then you press the junk mail button. So AI will learn, hey, you have the input data. This is the email. That is the input data. You have the label. Hey, this label is junk mail. So they understand the relationship of the junk mail. For example, from the title, from the presentation, from the work distribution, etc. Yes, I know that this one is junk mail. And then they start this kind of machine learning. And around 2010, the machine learning go to another extreme case. It's called deep learning. Deep learning is kind of neural network. Why we have the deep learning? Because we have the AlphaGo here. Here we have AlphaGo. AlphaGo is the Go, chess Go, right? So they always say that chess Go is the final intelligence application of human. If the human is beaten by the AI, that means, yeah, we lose all the things. Yeah, and that is true, right? Starting from AlphaGo, starting from deep learning. So lots of the parts we say that, hey, that is the final area of human, and then yeah, we lose it, lose it. Starting from this goal, and then today when you are prepare the document, definitely the AI prepare the document, prepare the writing is better than you guys, better than I will say that university graduate a lot. And then later, for example, the drawing, for example, the singing, because of the AIGC, they prepare lots of the brilliant work. And that is the brief history of the AI. So starting from 1950, and then we have a big jump in 2010 because we have the deep learning. And then I would say that the relationship set theory of AI is just like that. Set theory is here. So we have the AI, artificial intelligence, is the superset. Superset. AI contain the rule base. That means that if then else, they are the rule base. If then else is also the AI. So don't think that the if then else, this kind of the rule based system is stupid and then it's not AI, it's still the AI. And then we also have the rule-based system together with statistic tools. So we have the fuzzy and these kind of things. And jump into it, we want the machine learning model to learn the relationship of the input data. So we just gather all the data and then we give them the label and then ask them to classify the relationship with for us. And then when the new data comes, they can know that, hey, this is jump mail or this is not a jump mail. So we have different kinds of algorithm in machine learning. For example, support vector machine, and the others. Starting from 2010, so neural network have a big jump in AI in their algorithm design. So we have the deep learning. So today, lots of the AI application is based on deep learning. It's based on the artificial neural network. We will touch in the next lesson. Starting from next lesson, we'll touch it. So it's kind of neural network. Because of this one, so we have a lot of AIGC, AI generated content. We have the ChatGPT. We have lots of it is inside here. If you want to go deep, so deep learning, we have the transformer, and then transformer is inside here. So if you look at this one, AI is the superset, and then machine learning is one of the subset, and then inside the machine learning, another subset is called neural network. Inside the neural network, another subset is called deep learning, and that is the I would say that is the classification of AI, classification of machine learning. We need to introduce the other parts of the AI. So not only about the neural network, not only about the deep learning. So we also need to learn the other parts. So one of the, I would say, fundamental AI is called expert system. Expert system is, hey, for example, you are the doctor, you take care about the diabetics, and then you define rules for the diabetic. For example, diabetic, the rules is the blood test, the HbA1c test. The value is higher than 6.8. If is your value of HbA1c test is higher than 6.8, that means you are diabetic. So those are the expert system. The expert, for example, doctor, they list out all the if, then, else rules one by one, one by one, one by one. And then it formulate a human can understand rule-based system. They are called expert system. So expert system inside is a set of rules, lots of rules inside. So they are expert system. So that is the fundamental, the first AI system that we have used. Honestly, today, when you go to the HA, when you go to the CMS system, clinical management system, there are still lots of the rule-based system, expert system involved, because this kind of expert system, rule-based, is well known and it can be controlled, understand, reused by human, reused by the expert. So still is one of the bigger parts inside it. Just like here, when you want to use a expert system to do the I would say recognize a digit, that means 1, 2, 3, 4, 5, 6, 7, etc. To recognize a digit and express system, they work like a human. So how to identify digit 7? So they will identify, hey, whether you have a horizontal line, first step, horizontal line, and then you have a northeast here to southwest diagonal. So you have a diagonal line, and then you have a turning point at the upright. So if you have the patterns, I would say that you identify the key patterns of horizontal line, a diagonal from the NE to SW, northeast to southwest, and then you will have an upper right midpoint, then it's a digital 7. So this kind of the setting is similar to our expert settings. So it's similar to a expert to teach you, or a 7 is quite interesting, right? So for example, if you are in a kindergarten, so how a teacher is an expert to teach you how to write the letter 7, and that is how the expert system learn this kind of the rules. If I have the horizontal line, if I have the northeast to southwest diagonal, if I have the line meet at the upper right, and add them together, then it's a digital 7, and that is called rule-based system. Then I will have the 7. But when you go to some, I would say, more complicated example that is not easy to do it, or not easy to, I would say that identify all the things by some rule base or some relationship, because you have to code lots of the rules, and then if you want to classify the apple and orange, you have to code more than 100 rules to classify it. For example, if you want to classify apple and banana, sorry, not orange, banana here. So if it's red, then it's apple. If it's yellow, then it's banana, right? So do you think that is true, or is it enough? Not really, right? Because there are green apple, and then there are green banana, right? And then there are lots of the things that cannot use the wordings, and then cannot use the rules to clearly identify the relationship between the graphics. So that's why, or we that humans are lazy, can we use some computer algorithm to let the algorithm to understand the relationship from the vision, from the eyes, that they can identify the key feature. Otherwise, if I need to code one by one, it will become my nightmare. So you do it by yourself. You help me to do all the relationship. That is one of the interesting point of the machine learning. That is one of the interesting point of the deep learning. I prepare the data. You understand the relationship by yourself, and then yeah, you give me the result. You give me the machine learning. So keep this one as one of the, I will say that reflections. I will say that this one example. Hey, if I want to classify apple and orange, apple and banana, or apple and orange, what is the key feature I need to understand to identify these two? So maybe this one will be your quiz questions, and then yeah, just using a computer science uh, angle to identify which one is apple, which one is banana. So as I have mentioned before, and then the bigger part will be the AI, right? So here is the AI, and then the machine learning, and then the neural network, and then the deep learning, and then the transformer. Then you have the application of the OpenAI, etc., etc. So easier understanding is the traditional expert system. Traditional modeling is we have the data, we have the expert, that means the programmer or the doctor or whatever, they build the rules, they build the if-then rules. That is the traditional modeling. We put it into computer, then we have the result. For example, if the HbA1c value is larger than 6.8, then the subject is diabetic. So that is traditional modeling. Here is somehow machine learning is we collect the input data. We have the expected result labeling. For example, we have a set of the dog label, we have a set dog label image, or we have a set of cat label image, we have a set of apple, orange, banana image, and then we put it into computer. Computer will have the algorithm to learn the relationship of the photo, relationship of the input data. Then they will compile it into a model. This one, the model will put it back into the into the computer system. So when you have the new data here, you have the model, then we can identify this one is a dog, cat, apple, orange, banana, etc. And they will give you the result. So if your questions or if your computer science problem is easy to understand enough by the expert, then we use the traditional modeling, traditional method, because it's easy to understand, and then the computation power, the energy that you put it inside it is really low. So we use the traditional modeling. But if your problem is quite complicated, and then you are lazy, you don't want to find the relationship, or you don't want to find the answer, so you just let the computer to find the answer, then we use the machine learning approach. Is the below part is here. And in our course, most likely we will study lots of the application, lots of the interesting part with the machine learning. not the traditional program, it's the machine learning. Yeah, just like the traditional programming approach, we how to find the junk mail is we set up the rules for the email. For example, if the email is from bot@gmail.com and it's on Sunday, and then the file size is really large, and then it contains some image to ask me to buy this one or buy that one, is a sales message, etc. We give this kind of rules to your computer program. And then with the email come, we can identify this one is a junk mail or not. Okay, so that is the traditional approach. We have the rules. We identify the rules by the human. Traditional expert system or code rule-based approach is good because they just involve little computation power. Just a simple if-then rules is good enough. So even a small device, few dollars computer system can handle it. Unlike our machine learning model, you need lots of the GPU. So today, when you buy a GPU card, so it's few thousands to 15,000 or more. If you are buying some H series or A series GPU card, it costs you around 100,000, so it's really expensive. Traditional rule-based approach is really cheap. Few dollars computer system or $10 computer system they can handle within a chip. It's really cheap. But honestly, find the rules or define the rules is not easy. I would say that if you want to make sure that it's 100% correct, it's not easy to find the expert for you to code the rules. And then always the rules is ignored or there are some overlooked case by the expert. So we always find the exceptions. We always find that there are some special case that we cannot handle by the AI system, cannot handle by the rule-based or this kind of expert system. So we need the monitoring, and then we need someone to, I would say that expert to involve. So lots of the rule-based system, just like the CMS clinical management system in the HA in the hospital authority. So they are just a reminder, or they are just a, I would say that it's just a reminding system and then recommendation system that can help the doctor to facilitate some of the wording. So you still need a doctor to monitor, or you still need a pharmacist to monitor the whole system to make sure that all the things go smooth or go correctly. But the machine learning approach, when you are doing the junk mail, so is easier. So you just collect lots of the email, and then email there are lots of the, for example, they have lots of the property like break, and then the content, whether there are cells inside the document, where there are lots of the image inside the document, and there is a category of some product, etc., etc. So there are lots of the properties. And then it's a human, and then you define whether it's a junk mail or not. So you have the label. 0 is the not spam, and then 1 is the spam junk mail, and then you give this kind of label. So those are the data. Those are the data. So you have the properties of the email, and then you have the label of the data set. Then the computer, they can learn the relationship between the properties and then the data set. So when a new email comes, they know that it's a junk mail or not. So that is the machine learning approach. No human involved, just lots of the data, and then they can learn the relationship between different parameter. As a result, how this kind of parameter relationship to the junk mail to the final result or not. So as a result of machine learning, and you need training. So you need lots of the labeled data for the machine learning to do the training. So somehow you need, for example, if you junk mail, if you want to define a junk mail, it costs lots of our human to collect lots of the data, and then finally they can resolve to identify whether it's junk mail or not. For example, object detection, whether we identify this one is a car, or this one is a traffic light, this one is a human, this one is a apple, orange, cat, dog, etc., etc. It also involves lots of the human power to label this one. So do you remember you have experience in I'm not a robot from Google? Do you remember? So there are lots of the small graphic analysis that this one is traffic light, traffic light. This one is the car, etc., etc. Right? So this kind of small I'm not a robot tools is defined by Google, and then this kind of the tools help to facilitate in machine learning, help to facilitate in this kind of this kind of the approach to do the training. And of course, you need an algorithm. So an algorithm is study how the relationship of the parameter can resolve into a machine learning. We will learn this kind of algorithm later, maybe in the next lesson. And then those algorithms are the mathematical presentation, mathematical model. So if your middle school or high school, you have learned the M1, M2, definitely you have heard some of the algorithm inside, and then you know this kind of the settings. And then, for the machine learning, you need the data set. You need the input data. So most likely we'll collect a lots of the input data, and then you will experience this kind of exercise in week 3 and week 4. So we will prepare, you have to prepare some data sets for it. And usually we'll split it into two input data sets. The first one will be a training set. That means that 70% of the image or data will be used as a training. And another 30% of the data set will be used as the testing data set. That means we want to test two kinds of things for the machine learning. The first one is whether the machine learning model, they can remember all the things in our training data set. Another, if they experience in new data set, whether they have the ability to handle the new data set, new information from the real world. So that is our data set preparations, 70% and also 30% separation. So if you have prepared the data set, so for example, you have prepared a algorithm, a model that can identify the cat and the dog image, where cat image put inside it, so they will try to match the feature or match the relationship of the image to see whether the image, new input image, that is the cat image here, the cat image, fit the feature of the training model. And if it fit the image training model feature, then we say that, hey, this one is cat, this one is not a dog. So honestly, we have lots of the data set that is related to this kind of training model. So in Google, we have an ImageNet. ImageNet, they contain lots of the data set that is related to the mammals, related to the dog, related to the huggies, and then there are lots of classification in the hierarchical training. For example, is a vehicle, craft, water vehicle, etc., etc. So those are the data prepared by we guys, human, prepared maybe by you. Just like I'm not a robot, so we guys and also human involve lots of the power and then contribute into this kind of data set. But honestly, how can you identify this is a cat from the screen by using your eyes, by using your visions? So just like here, when you want to teach a baby, say that this one is cat, this one is cat, this one is cat, and then you need to explain what is the feature from the image to identify this one is a cat. So do you think you can do it? So this one is also a cat, right? And then this one is also a cat. So can you find some interesting feature to identify the cat image? Perhaps I will leave this one just like the apple, banana, cats, and dogs. I will leave this one as one of our quiz questions. So what is the feature of a cat? So how can you identify this is a cat by using image? So honestly, for the data sets, when you put it or for example, cat image, we label is cat, cat, cat. Label this one dot image, dot, 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 mark, 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 etc. into a machine learning model. So when you put a new image that is cat, they can identify the feature inside this image and then say it, hey, it's a cat with the confidence. Here is 99%. honestly, machine learning, they cannot 100% identify this one is cat or this one is a dog, etc. They will give them their confidence value. For example, this one, I can say this is a cat 99%, maybe it's a true, it's a cat. So that is our confidence. When the confidence increase, so we are more and more sure that this one is a cat. So cats is I would say that a question leave for your quiz, leave for your assignment or project. So maybe you use some artificial things that will be easier to explain how the machine learning or how the AI model learn the feature of an image, and then say this one is a car. Because car is easier to understand. So can you name some feature of a car? For example, from the image, you can identify there is a wheel, so there is a windows, etc., etc. So machine learning, we learn the feature. We try to squeeze the image into small and small part. And throughout this small part, we can identify some of the common feature, or I will say the patterns inside this image. If there are lots of the image together with the our vector. So for example, we have 100 image, and then there are 99 image correct with bingo, 99 image. We are quite confident and say that this one is a car. So let us look at a car image. When a car image, they put it into low feature, lower level feature, so we can identify some common patterns of a car. And then we squeeze the image into a small image. So this kind of the feature will be more and more easy to observe. For example, a car, right? Definitely we can find some wheel. Can you see that? There is a wheel patterns. There is a wheel pattern. There is a wheel patterns. When we squeeze the image in a small image, this kind of wheel here image will be more easy to observe. So if we have this kind of the feature, we are more and more confident say that this one is a car. So the wheel, the circle, this one is one of the feature that we can say that this belongs to a car, this belongs to a car. Of course, there are lots of different features you can observe from a car. For example, you have the windows, you have the patterns just like a balls, etc., etc. So those are the we call it image feature, and this kind of image feature can be identified by the machine learning, by the algorithm by themselves, and this is called machine learning. So yeah, machine learning is some human learned from experience. So we don't know why, but we label it. This one is car, this one is cat, this one is dog. We put lots of the label in the data set, put all the things into the algorithm, and then the algorithm learn the feature, learn the relationship between the image. For example, the car, we have the circle, we have the wheel, we have this kind of pattern. If we can find this kind of pattern inside image, definitely we can have car. So try to use this kind of thinking and then think what is the feature of a cat. So let me give you an example. Feature of a cat, lots of the cat, they have an M patterns on their head. Okay, so that is one of the interesting things from the cat. If you wear a cat, so it's easy to find a M patterns on their head. So that is one of the interesting things. Of course, you can also identify a cat by using their tails, identify a cat by using their ear, etc., etc. So those are the image feature. And then this kind of image feature can be learned by a computer algorithm, by computer visions. Machine learning can be classified into different parts. For example, in our course, we will classify them into supervised and unsupervised learning. Supervised learning means that we have the sample data together with the expected result. So we prepare lots of the data that is cat. So we label the image cat. We image the label the image as dot, 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 etc. So those are the sample data together with the expected result. Then we'll do the classification. So for example, is a cat. So we have the classification. This is cat, this is dog, this is banana, this is apple, etc. And then supervised learning can be also do with the regressions that we will learn later. classification is used to classify something that is discrete data. For example, cat, dog, they do not have a linear relationship. Regression is doing something that they have the linear relationship. For example, the continuous data. For example, the height. For example, the salary. For example, the age, etc. So the age you have the 0, 1, 2, 3, 4, 5, 6, etc. Height you have the 30 something, starting from 30 something to 40 something, and then to 200 something. So they are the continuous data. Salary is also continuous data. So when you use the continuous data, it's called regressions. So if you give the sample data, if you give the expected result, then we will return a certain number, and this is called regressions. For the classification, they will give you cat, flower, dog, banana, etc., etc. So this is discrete data and doing the classification. We also have something called unsupervised learning. We'll do it later. So most likely it's used for the clustering. We only have a set of data, but we don't know the label. We do not know whether it's a cat or dog, or whether what is the relation inside. We don't know. So we just give a bunch of data into it, and then they will machine learning will help us to do the classification. To do the clustering, or the machine learning will help us to do the dimension reduction. So this one we will have a look with the classification, have a look with the regression, also have a look with the supervised learning, and then inside our basic machine learning and the AI process, we will touch a little bit about this kind of thing by using some example. Yeah, those are the data from the machine learning. So it can be numeric data. So numeric data is 1, 2, 3, 4, 5, and then they have a linear relationship. So somehow this one will do it by using regressions. And then if it's a categorical data, and for example, cat, dogs, etc., then we'll do the classification. So for our machine learning. So those are the classification of the machine learning method that you have to understand before our lesson start. So yeah, we have talked about the feature on the image. For example, you have the M of a cat. You have most likely apple is rounded angle, and then banana is just like a moon. So you have some feature. So feature in the machine learning is really important, and then we want to understand the feature, and then feature is usually the input data may be collected by yourself or image collected by yourself. So you have to find out some data, input data set that can represent the feature very well. Cats, you have to find out lots of the image about their ear, about their nose, about their fur, neck, tail, etc., etc. If it's a house or a flat, so you have to collect the feature of a house. For example, the size, for example, number of bedroom, for example, bathroom, whether it's near the school or not. For example, I want to do a regression. I want to estimate the price of a fat, right? Hong Kong people, we always care about the price of the fat. So those are the data you have to collect for your input data set. So whether we can have a better estimation about the price of the fat. Yeah. So those are the example of the machine learning algorithm. So we have the key nearest neighborhood, we have the decision tree, we have the support vector machine, regressions, neural network. So in our course, most likely we will focus lots of things about the neural network. Neural network, convolutional neural network, deep learning, etc., etc. And that is the trend of the machine learning. So yeah, they can do lots of the things, just like the previous one. We use the teacher machine to identify the COVID-19 X-ray data. So we can also use this kind of machine learning to understand the feature of the image to identify whether it's a breast cancer or not. So this is one of the interesting points of the current research, not current research, more than 10 years or 20 years. So they want to understand what is the relationship, what is the things that we want to learn more about the predictions. Yeah, so those are the data fields of the lung cancer. So you can change it into numeric data. And then inside the numeric data, you can do the classification, and then you can do the prediction whether they have the diagnosis, they have the lung cancer or not. Again, the most important things for the machine learning is the data. Without meaningful data, we cannot do anything for the machine learning. And then, yeah, after you have start to prepare the image, so somehow we can use it to predict the model. And then with the predict model, you can have lots of the accuracy. You can plot lots of the beautiful graph inside our class. So in your week 3 and week 4, so you will experience in this kind of plotting the graph. So you will learn more later on how we are using the data to plot some beautiful graphs, especially you want to ask for a better grade in your examinations.